Hi, welcome to my channel Cloud with Girish. In my previous video, I explained how to create a CI/CD pipeline to build and deploy a simple Lambda function integrated with API Gateway using AWS SAM and GitHub. While building this solution, I temporarily assigned broad permissions such as full access to services like S3 CloudFormation, Lambda and API Gateway. Assigning these full access permission is against the principle of least privileges. That means grant only the specific permission required. In this video, I will focus on replacing these broad permissions with a custom fine-grained IAM policy that only grants the permission required by this pipeline. This approach aligns with AWS security best practices and the principle of least privilege, helping reducing security risk and improve overall security posture of the AWS environment. Before diving in, let's review the architecture diagram to understand how these components interact. Let's look at the architecture. So in the first part of this architecture design diagram, we have a flow indicating that there is a user that's invoking an API. That API is hosted in API Gateway. It's a secure API. It's using the API key and usage plan, and then it's invoking a Lambda function. Lambda function is using integrated CloudWatch log, and this entire flow is built using AWS SAM, which is serverless application model, using the infrastructure as code approach. Now, we want to have a Git repo here, and this Git repo is integrated with the code build, which is another service, and S3 bucket for the artifact, and code pipeline is orchestrating the flow where anytime a code change is committed to the Git repo, it will actually trigger the code pipeline and it will update the Lambda function, resulting in the API to return a more up-to-date response depending on the code changes. Prerequisite for this workshop is familiarity with AWS Management Console, basic understanding of AWS CLI, basic understanding of AWS SAM, Lambda, API Gateway, and a basic understanding of CI/CD pipeline and GitHub. And most importantly, make sure you have watched my previous video on this CI/CD topic, link below and in the description. I won't repeat the content here, but understanding it is essential for following along with the custom policy setup in this video. Let's get started. We're going to look at a quick review of CI/CD pipeline from prior video, why use a custom policy, we'll review a custom policy, and then we'll push a code change to Git repo and monitor the AWS code pipeline, and then review the S3 bucket for code artifact and validate the updated Lambda function using Postman. Review CloudWatch log and cleaning up the resources like deleting the pipeline and so on, so that we don't incur the cost. So quick review of the pipeline that we created in the previous video. Like I stated, please do watch it. It has all these step-by-step instructions, and the idea is to create a very simple CI/CD pipeline for a hello world Lambda function, which is getting invoked via the API, and it's integrated with the GitHub repo. Is using the AWS SAM, the serverless approach and IAC approach to build the Lambda function and the API and deploy it in the AWS cloud. So that is the part that we completed in the part 1. So now with this, let's look at like why use a custom policy. So using custom policy for CI/CD pipeline offers several advantages for enterprises. Principle of least privilege is an important factor for overall security posture. By implementing the principle of least privilege, you can significantly improve your security posture and operational efficiency. Custom policies can help in several areas, including limit the potential impact if credentials are ever compromised. So an example is that you are restricting the S3 access to only specific bucket used for SAM deployment artifact rather than allowing wildcard access to all buckets. So like if a credential compromise happens, then you are not risking all your S3 bucket. Another example is that limit the CloudFormation permissions to only the named stack used for deploying the Lambda and API resources for this particular function. That way, again, you are protecting all other your CloudFormation stack in the case of a security compromise. Awareness of what permission their automation requires. So that's another benefit, because if you are thinking about from a principle of least privilege, then you need to know that, hey, I'm using this DynamoDB, or I'm using a Lambda function, or I'm using an API get method or a post method, and then you can tailor the permission specific to those. And also like talking about API gateway, you have different stages. You have dev, test, prod, so you can tailor it to a specific stage, specific method. Another advantage is that prevent unintended resource creation or deletion. So this goes to like you can have your deny accesses, you can restrict accidental loss of critical deployment artifact. And then support, document, and demonstrate security control required for compliance. Any big enterprise need to follow certain rules as part of the governance and the compliance for variety of reasons. So here is an example where if you create a IAM policy that clearly defines allowed action, like, hey, Lambda can only update the function code, or API gateway for this API can only support post, and so on. So that will demonstrate that you have an audit-ready IAM documentation showing that CI/CD pipeline operates with least privilege. Let's look at our custom policy. So this is an example of custom IAM policy tailored for a CI/CD pipeline that deploy a Lambda function and API gateway using AWS SAM. This pipeline is triggered by a code push to a GitHub repo and use AWS code pipeline and code build to build and deploy the serverless application. The policy grants only the necessary permissions to interact with Lambda, API Gateway, S3, and CloudFormation, following the principle of least privilege. These are different sections around these permissions baked into this custom policy that is going to be used for this CI/CD pipeline. So let's look at in this a bigger view here. So if you see here, there is like a statement, and here we're saying that, hey, for the S3, this is the bucket where this policy apply, and it supports the get object and put object, right? So basically it's very specific, it's specifying the resource, so it's only gonna apply to this bucket. And then if you look at like CloudFormation, then again, there are specific permissions, and those permissions are in the context of the resource that I'm providing. And that resource is really the stack that I'm creating for this CI/CD pipeline. Same apply to, if I look at like Lambda, so again, I'm specifying the specific Lambda function, and all these permissions are applicable to that Lambda function. Same thing for API gateway is specific to the resource that we have, and so on. So this is an example of a custom policy where you're providing a specific permission for a specific resource rather than providing like a admin permission or a full permission and on all the resource, which is typically indicated by like a wildcard. So this is an example of the policy, and once you have the policy, basically you attach it to the role that you have for the code build and code pipeline. Like I stated before, I'm not repeating those steps about the role or step by step to create the code pipeline, because that I have already documented in the part 1 of this series. So I will again highly suggest that you go back, look at that part 1 of this, and be familiar with those steps that basically integrate the GitHub repo with the code build, and code build is integrated into the code build pipeline, and how the AWS SAM is building the artifact related to AWS Lambda and the API that I'm using for the very simple hello world function and the API example. Now, once we have this policy attached to our role, that means our build role, our pipeline role now gonna use this custom policy. So let's make a change, right? The next logical step is that we push a code change to Git repo. So when you push a code change to the Git repo, it will trigger the pipeline. And because now pipeline has this custom policy, then it will look for all those permissions, it will find those permissions, and it will execute the pipeline. Now, permissions are very specific to this particular function and the bucket and the API. So again, that policy will not work for like a different tech stack, right? If you have a different function and a different API, and that means you have to create another policy, and could be similar, could be different, but you have to name resources. But that is the power of that custom policy, right? That's by design, because that's what you are controlling. So again, let's make a change to the Lambda function and commit the updated code to the Git repo. And once the changes are pushed, this will automatically trigger the AWS code pipeline. So after the pipeline is start, they will review the build and deployment stage to confirm the updated function is successfully redeployed. Now, our use case is to make sure that code pipeline get triggered every time we make a change. So to validate that, let's make a change to the Lambda function and commit the updated code to the Git repo. Once the changes are pushed, this will automatically trigger the AWS code pipeline. And what I'm doing is, in this Lambda function, I'm simply updating the message hello world from Lambda to hello world from Girish, and I'm gonna commit the changes. The commit should actually trigger the pipeline, and then it will go through the build stages. So if I see here, as soon as I push the code change to Git repo, I see that pipeline has been kicked, and again my build is in progress. And because I already have all the build issue resolved, is actually gonna go in like all actions succeeded. What that means is that at this point, it has actually retrieved the code from the GitHub, and it has deployed it, it has built it, and it has deployed it in the AWS cloud. That means I have a refresh Lambda function, so I should not get the same response from the Lambda function which I was getting before. So to validate that, I can trigger the same API again, and if I do that, then you see here that I'm getting hello world from Girish, which is a new message that now I have put. So this confirmed that changes were successfully deployed. Now I can also review the S3 bucket for code artifact, because in my code build project I said, hey, store my S3, like all the build artifact, store it there, so I can see these artifacts are there. And then I can also look at my CloudWatch, because CloudWatch is integrated function. So like I have a dedicated log group, and I'm seeing all the logging message in the CloudWatch. Very helpful for typical debugging, the observability, and looking at that what's going on inside the code. Now, once you have completed the exercise, make sure to delete all the resources created to avoid unnecessary charges that could impact your overall cloud cost and budget. In particular, remember to delete the following: delete the AWS code pipeline, delete the AWS code build project, any S3 bucket used for artifact, and then Lambda function, API gateway, and associated CloudWatch log group. If you created a new IAM role, then delete those also if they are not going to be reused. In this workshop, I demonstrated how to build a custom IAM policy for a Lambda CI/CD pipeline using AWS SAM and GitHub. Using a custom policy helps ensure that the code pipeline adheres to the principle of least privilege, keeping your AWS resources more secure. I hope you found this tutorial both helpful and informative. I'm constantly working on new content covering various AWS topics, so please take a moment to like this video and subscribe to the Cloud with Girish channel. Your support helps me continue creating valuable AWS tutorials and workshops. Stay tuned for more exciting content. Thank you.